Hey everyone, and welcome. So today, we're going to go on a bit of an investigation. We're diving deep into the world of data science to figure out how one programming language, Python, became the absolute go-to tool for uncovering hidden truths in data. So let's kick things off with the big question, right? The central mystery. You've got this mountain of data. How in the world do you find the story hidden inside? How do you turn all those endless rows of numbers and text into something that actually makes sense? Well, that's the case we're cracking open today. All right, let's get right into it. What is data science really? You see the subtitle here, The Art of the Answer. And you know what? That's a perfect way to put it. Because it's not just about crunching numbers. It's more like being a detective, hunting for clues that point you to a solution. Yeah, at the end of the day, data science is all about finding that signal in all the noise. It's this whole process of taking raw, messy information and turning it into real wisdom you can act on. It's about spotting those key insights, those trends that help leaders make smarter, way better decisions. And here's the thing, a great data scientist isn't just one type of expert. They're kind of like a whole team rolled into one person. You've got to have that industry smarts, that's the domain knowledge. Then you need the right kit, your tools and technology. You absolutely need the logic of a mathematician. And on top of all that, you need that creative spark of a real problem solver to piece all the clues together. Okay, so we've got the what down. Now let's talk about the how. Every good data detective follows a playbook, a really structured process for solving these data mysteries. And this process, it's super methodical. You can't just jump in. First, you have to state the problem you're trying to solve. Then comes data preparation, and let me tell you, this is where most of the heavy lifting happens. After that, you're selecting features, exploring the data, building a model, and then testing it like crazy. It's just like a real investigation. You absolutely cannot skip a step. But wait, the job's not done yet. An amazing insight is totally useless if nobody gets it, right? So communicating what you found is absolutely crucial. Then you've got deployment. That's putting your model to work out in the real world. And the last step, it's this constant loop of getting feedback and making things better. Because the story the data is telling, well, it's always changing. So you have this whole playbook, this process. But what's the number one tool in the modern data detective's belt? Well, for a huge number of people, the answer is just one word: Python. So why Python? I mean, what makes it so special? Well, first off, it's pretty easy to learn and read, which is a huge plus. Second, it's so popular that there's this massive community building new tools and helping each other out all the time. And maybe best of all, it's open source and totally free to use. That combo of being powerful and accessible, it's pretty much unbeatable. But here's the secret. Python's real power isn't just the language itself. It's the whole ecosystem around it. It doesn't work alone. Think of it like that detective's forensic kit we talked about, packed with all these specialized tools for every single part of the investigation. In the Python world, we call these tools libraries. All right, first up in the toolkit is NumPy. This is the workhorse. It's the foundation for all the heavy-duty math and number crunching, and it does it super fast. But let's be real, data is almost never clean and tidy. That's where Pandas comes in. Pandas is your go-to tool for taking all that messy, table-like data and cleaning it up, wrangling it into something you can actually use. Okay, so your data is clean and organized. Now you've got to see what it's telling you, right? Enter Matplotlib. This is the artist of the group. It lets you create all kinds of charts and graphs to actually visualize the patterns that were hiding in plain sight in all those numbers. And then, for the really cool advanced stuff, you've got scikit-learn. This is where things get, well, almost magical. It's the library that puts seriously powerful machine learning and predictive analytics right at your fingertips. It's a total game changer. So all these tools we've been talking about, they all build up to one of the most exciting fields in tech right now: machine learning. And what is that? Well, it's basically about teaching computers how to think. So what does that mean, teaching computers to think? At its core, machine learning is all about letting computers learn directly from data instead of us having to write code for every single rule. The whole point is to create models that can spot patterns and then make predictions on brand new data they've never seen before. And believe it or not, you use this stuff every single day. Machine learning is the magic behind the curtain that decides if an email is spam or not. It's what flags a weird transaction on your credit card. It's what recommends that next product you're totally going to buy. its power is literally woven into our daily lives. Okay, this is super interesting. It turns out there are two main ways a machine learns. First, you have supervised learning. That's where you give it labeled data. Think of a bunch of photos labeled cat or dog. The goal is for it to learn from those examples to make predictions. Then you have unsupervised learning. Here, you just dump a bunch of unlabeled data on it, and its job is to find hidden patterns, all by itself, like finding different groups of customers you never even knew you had. So here's the main takeaway. Data science isn't magic, not at all. It's a really disciplined, powerful process. When you combine that clear, step-by-step method with these incredible tools like Python and its libraries, well, that's when you can systematically uncover some amazing, super valuable insights from the data that's all around us. And that leaves us with one last, pretty fascinating thought to chew on. We have the tools. We have the process. We can literally teach machines how to find the hidden stories in all the world's data. So the only real question left is, what problems are we going to ask them to solve next?